Today, they're going to prove the law of sines. And the law of sines states that the sides of a triangle are one to one another in the same ratio as the sines of the opposite angles. In other words, we have here that of A, side A, over sine A, the sine of A, is the same as B, or here, let's look over here, B over the sine of B, and the same thing of C over the sine of C. So in order to, this is what I'm going to try to prove, and I'm given this triangle ABCD. And what I've done is to construct an altitude for it. I label this as H in this case right here, which of course divides these sides up here being X and obviously this whole side would be B. So if this is X, then this side over here has got to be B minus X. So I'm going to try to prove those, and we start off right here with our given, restatement of our given. First thing is to define what sine A is. Sine A, of course, is going to be the opposite over the hypotenuse, which means the opposite, which is H, which is the height in this case right here. So the sine is going to be opposite over the hypotenuse, which is C. And then if I cross multiply this, where I'm going to solve for H, so C times the sine of A, so that's end up being an H is going to equal to C times the sine of A. That's the definition of sine, and by the cross multiplying. We constructed the triangle of CBD here when I put this altitude in for this triangle. So from there, I'm going to go ahead and say that sine C now is again the opposite over the hypotenuse, which is H, which is the opposite over the hypotenuse, which is A, which is the long side of this for this triangle right here. Okay, so and again, if I solve for H only, it'll end up being A times the sine of C. Again, that's by the definition of cross multiply. Now, if I set, since both of these are H, both of these H's equal to these, so therefore this C sine A, it was going to equal A times the sine of C. And that's just plain by substitution that we have there. Now, if I divide A on both sides and C from both sides, I'll end up with sine A over A and sine C over C by division. Okay? Now the next is, using the same triangle, except I'm going to create a new height for it. And in this case right here, we'll have the sine B, as you can see right here, sine B is going to be the opposite, which is going to be H over C, okay, which is going to be over here, which will be the hypotenuse. So in this case right here, H is equal to C sine B. And since creating this triangle right here of this triangle right here, CAD, okay, then from that right there, which is, again, by drawing the height in this case right here, I can look at here and say that C is going to be equal to the opposite, which is going to be H over B, which is we have, as you can indicate right here. And so therefore, that's going to end up being H is going to equal to B times the sine of C. And if I set these both of these, since both of these are equal to H, therefore they're going to end up being C sine B equal to B sine C. And if I divide each side by C and B, I'll end up with sine B over B equals sine C over C. And transitive. So therefore, if these two equal and these two equal, therefore, if I notice over here, it didn't have enough room, but as you can see right here, is that sine A over A equals sine B over B, and sine C equals C sine C over C. And that's all done by the transitive. So we have proven, therefore, that these have the same ratio in relationship to each other. So thank you.